Hey everyone, we're moving on to question 12 in the 2019 B test. The question reads, two planets A and B have masses ma is equal to 2mb. They orbit a star in circular orbits of radius Ra is equal to 3 Rb. Let E, I, and Li be the kinetic energy and magnitude of the angular momentum of planet I respectively. Which of the following is true? This is actually one of the more straightforward problems on the test. Let's start off with drawing a diagram of what this represents. So we can have our star here, the sun maybe, as a single point in space. And we know that the mass of A is 2 times the mass of B. We also know that the radius of A is 3 times the radius R. So let's draw A first. So this is MA is equal to 2MB. And this radius RA is equal to 3RB, and that means that the radius of B is smaller than the radius A, so let me draw the radius of B here and call this MB, and this is RB. Okay, so now we want to compare the kinetic energy and the angular momentum of each planet. So if we remember, what's the equation for the kinetic energy? So kinetic energy obviously is 1/2 mv squared. Okay, so in both of these cases, we were given the mass of the planets. So that is taken care of, but we aren't given the velocity of the planets. So let's try to figure out what's the velocity of these planets. What we can do is we can use centripetal motion, right? So obviously only gravity is holding the planets in rotation. So we know that the acceleration due to gravity, or we just know that the force of gravity has to also equal the force of centripetal acceleration, which is mv squared over radius, right? And this is where we get our v squared from, right here. So we know that Fg, the force of gravity, is big G times mass of the planet, so I'm just call it planet, times the mass of the sun or whatever star, all right, divided by r squared. Okay, so this is also the mass of, right here, this m represents the mass of the planet, right, because it's talking about whatever is rotating around the star. So we can cancel out these guys, and we get that v squared is equal to, and then this r cancels out with this squared. V squared is equal to g, mass of the sun, divided by r, okay? So if we plug that into here, kinetic energy is 1/2 m g ms over r. And so I'll put all the constants to one side because we don't need to worry about the constants. So that's 1/2 g and ms. They're all constants, but the only thing that are variable between these two planets is the mass and the radius. So you can see that kinetic energy is directly proportional to mass over r, right? So let's look at the kinetic energy of mass of planet A. So kinetic energy of A, and that's going to be proportional to the mass of A over the radius of A, right? And since we were given it in terms of B, let's just write it in terms of B. So mass of A is equal to 2, mass of B divided by, and then 3 radius of B, right? And kinetic energy of B is proportional to just MB over RB. So as you can see between these two, obviously the kinetic energy of A is smaller than the kinetic energy of B. So if we look at here, that leaves these two answer choices, okay? So now let's look at the angular momentum. So if we remember the equation for angular momentum, there's a couple equations. One of them is linear momentum times the cross product of the radius, or mv cross r, or is it, I think it's, let me see, is it r cross v or is it v cross r? So that's my bad, it's actually r cross v, but in this case it actually doesn't really matter because they are perpendicular at all points anyways. Remember, that's what cross product means, so you're just looking at the perpendicular component. So that's equal to MRV, let's say MRV, okay? So again, we know the mass of each planet, we know the radius of each planet, but we're not really given the velocity of each planet, but we already calculated what the velocity is right here. So that means that velocity is equal to square root of gms over r. So let's plug that into this equation right here for the angular momentum. So that's equal to mr times the square root of gms over r. And again, I'm not really going to care about these constants because they don't really matter between the two planets. So I'm going to say this is proportional to, and I'm going to move the r inside the square root by taking r squared. So then I can put it into the square root divided by r times this mass. So it's just equal to m times the square root of r. So L is proportional to m times square root of r. So now let's look at L of A and L of B. Okay, so L of A is equal to m of A times square root of r of A, which is equal to, or I should say proportional to, 2m of B times square root of 3r of B, and L of B is proportional to just mb square root r of B. So now you can notice that L of A is greater than L of B, right? And that gives us this as the correct answer.